There's an example in the book on page 520 through 521 that talks about a hospital considering investing in a project that generates future cash flows of a certain amount that are sufficient to cover the initial investment amount into the project. And I want to use this as an illustration to talk a little bit more about present value and internal rates of return, etc. The particular problem starts off by saying, look, the amount the project requires upfront is $3,170. Considering that amount is done today at time zero, the discount factor, there really isn't one. So you could consider this just multiplying by 1 to get what the present value is today of that initial investment. It seems ridiculous. Just go with me on this. The amount of cash outflow is $3,170. Now, the authors say, look, the hospital is requiring a rate of return of 10%. What would that generate in terms of future cash flows that are sufficient enough to cover, at the very least, cover the 3,170 that we are initially investing in the project? And I think we need to sort of break this down and use sort of like a similar example in terms of an investment portfolio. So let's deviate away from this project for a second. But first, before we do, the authors state that the projected net cash inflows are $1,000 per year. And the way they come up with this is they look at that initial investment and they determine that based on a required rate of return of 10%, the net cash inflows must be $1,000 each year in the future of a consistent amount. How did they come up with that $1,000? Where is that derived from? Well, it's mostly it's the interaction between the rate of return and the initial investment. What we can do is think about these initial flows as returns, as a cash out from separate investment portfolios. Specifically, if I take $1,000, if I expected this $1,000 received 1 year in the future, if I expect to invest a certain amount today, have it grow to $1,000 and then cash out, what would that amount I need be today? The way I would determine that is I would go to my table and look at a return of 10%, and then for one period go straight across, and I would see that that $1,000 in the future is worth, for me today, about 90.9% or $909. Now you can use these tables to find the individual factors and just plug them in. Personally, I prefer to use the present value formula because it's more accurate. So if you want, type in PV, the rate being 10%, number of periods in this case being 1. Ignore the payment and go right to the future value of, in this case, it's $1,000. But if you're just trying to get the factor, just put in 1, because that's essentially all you're trying to do. All these factors in the table are based off of a future value of 1 or $1. Type in 0, and that is your factor. And now what we can do is, assuming we did the formula right, hit F4 for those rates and just copy it over to the right. So all these factors are what you see in the table here that I've highlighted or circled in red. These are the individual factors applied to future amounts we expect to receive. The reason why we use these factors is we're trying to determine today, what is $1,000 received 4 years from now? If I want to find that out, multiply that 1,000 by these factors to discount the amount to a lower value today. Why am I doing that? Well, think about it like this. I'm looking for a return. If I know I can get a return investing in some stocks or bonds, I can set up different portfolios of these amounts. And I'm going to do that right here. So if I have a portfolio of $909, a portfolio of $826, portfolio of 751 and a portfolio of 683. And I invest these different portfolios at time 0. In the future, I'm going to generate a return, and then I'm going to cash out at various points in time. If I want to know what amount I can expect in the future from $909 1 year ahead, I know it's going to be $1,000, but why does it work that way? Let's reverse engineer this $1,000 that we calculated. If I invest $909 at 10%, I'm going to generate $90.91. Meaning that when I cash out at the end of that 1 year, I will get the initial investment plus that $90 or $1,000. If I look at the second portfolio and I say, look, what's my return from this 826 in year 1? Well, just go equals 826 times the 10%. I'm going to generate 8264. But I'm not going to cash out after 1 year. I'm going to cash out after 2 years. So in year 2, I'm going to get the 826. I'm going to get another year's worth of interest. But I'm also going to get a return off my previous year's return of 10% because I reinvested those funds. So $91 is my return for year 2. If I cash out at that point in time, the 826, I'm going to get back my 826 plus the prior year's return plus the return earned from the 826 plus the 8264, which was $91. And guess what? That equals $1,000. And they can keep doing that going forward. And guess what? Each one of these amounts is going to be $1,000. But let me sort of illustrate another way of sort of putting this in. If I looked at the 909, my initial investment, and I said, what's the return? And just plop that in there. And that's what I'm going to do. I'm going to F4 that bad boy and copy it down. After 1 year, each one of these portfolios is generating 10% of its initial amount. But after year 1, I'm going to cash out this portfolio. So equals this plus this guy here too. So $1,000, the 2 different amounts. I'm no longer going to worry going forward about that investment portfolio. I've cashed out that portion of the investment. Going forward, starting in year 2, I have all of these 3 investment portfolios, plus their returns, which are also reinvested. So I'm not just investing 826 for year 2. I'm investing the sum of those balances there. So what does that equal? Well, you can do it in different ways, but like we did above, I would simply go, what's the sum of this times 10%? That's the amount I'm generating from this portfolio for year 2. It's the combination of the initial amount, earning 10%, plus its prior year return, earning another 10%, or just the sum of the 2 times 10%. I do the same thing for the other 2 portfolios. But at the end of year 2, I'm going to cash out this portfolio. So the initial investment I get back, plus the returns earned from the entire time it was invested, equals $1,000. I'm no longer going to have that. I'm going to cash out from that. And now what I'm going to do is the same thing you saw before. Sum all the entire investment portfolio times the interest, the rate of return, 4%. Move that down. And again, the reason why we're doing that is because every time we get a return in these portfolios, we are reinvesting into the portfolio those returns. So 75.13 and 82.64 are now generating 10% each. So that's why you have exponential growth. Compounded interest or compounded growth is exponential. And that's what makes investment so powerful. The more you have to invest, obviously, the greater the amount you get from a certain rate of return. But if you just reinvest those earnings year over year, it just grows exponentially. I'm going to cash out from this guy. And the cash out amount is the initial investment plus the returns earned today. And then finally, I'm going to, for the last year, multiply the entire size of the portfolio by 10%. And guess what? That's the return. The total amount I cash out is going to be $1,000. This is how essentially they're generating the $1,000 above. They're saying that, look, if I know what the amount is, what $1,000 is worth today, I'm essentially saying that if I invest those amounts now, I should expect to receive a total of $1,000. If I invest $826 today and cash out after 2 years, I should have $1,000. $1,000, $1,000. That's how they're coming up with these amounts. They're saying a rate of return 10%. These cash flows will be as such given that I break out my individual investments into 4 different portfolios as follows. Okay. So what is then, going back up to the top, what is $1,000 worth to me if I receive $1,000 1 year in the future? What is this amount worth to me today? The amount it's worth to me today depends on what I could do with the money today at a rate of return of 10% or whatever that will generate that $1,000. If I suspect the rate of return is only 7, well, that's going to change my discount factors and everything else that goes on. But we'll keep it at 10% because that's part of the project, part of the problem in the book. $909, that's what $1,000 is worth me today because I can invest that, cash out after 1 year, and have $1,000. What is $1,000 received 2 years in the future worth to me today? Well, if I invest $826, cash out, reinvest those earnings, cash out after 2 years, I'll have that $1,000. If I want $1,000 in 3 years, I only need $751 invested. Reinvesting the earnings at 10% compounds that up to $1,000. So all of these discounting amounts are basically my critical way of viewing an amount to be received in the future. Given that I know what those individual cash flows are worth to me today, sum those up, and this 3170 represents the discounted, the present value of the net future cash flows, 3170. It just so happens that the amount of cash flow offsets equal in full the amount that we're investing. So the net present value is 0. Well, that's not very exciting. But the book says having a net present value of 0 is fine. Well, yeah, if you're a hospital or a nonprofit organization, but generally we want a net present value of some higher amount, generally speaking. But they were saying that they needed at least $1,000 in the future. If they feel that 10% rate of return is a decent rate of return, then $1,000 received each year in the future, discounted back, would equate and offset that 3170 investment. So they came up with this 10%, and we're using this 10% rate of return as essentially a discount percent, because we're saying what I can get generates something in the future, so let me discount that future amount back to what I need today. So when a rate of return equals the discount factor, you have essentially a net present value of 0, for sure. But you need to understand that when you have a net present value of 0, that means that your rate of return, ROR, percentage, equals your discount percentage. They didn't really discuss this in too much detail in the book, but what that means is you have an internal rate of return of 10%. An internal rate of return of 10% means that that not only does our rate of return equal our discount, it means that if we want the net present value to at least be zero, what is the amount, what must the internal rate of return be to make this happen? Given an investment of 3170, we need a rate of return of 10%, which generates $1,000 each year for 4 years. And when we discount that back using that exact same amount, we find that the sum of all these future cash flows discounted equals that project's initial investment. Hence, net present value is zero. Generally speaking, if the discount rate is equal to your rate of return, your net present value is going to be zero. It's just by math, this is the way it works out. But it's kind of hard to just disentangle why they're doing it that way. So when you're thinking about cash flows and why we discount things back, think about it like this. We're being critical about discounting these flows because we could, if we wanted to, invest those amounts in such a way that they generate those future cash flows. And we wouldn't that's our opportunity cost. We can invest in stocks or bonds, or we can invest in a project that generates net operating income of a certain amount to us. What do we want to do? If, as in the case of where the discount rate equals the rate of return, you're going to find a net present value of zero, meaning that your internal rate of return equals your rate of return and it equals your discount amount. The problem with this is, given that this is a hospital or nonprofit, your profitability index is going to be zero. Because this profitability index is calculated, you're taking your net present value and you're dividing that by your initial investment amount. So in this case, zero is your net present value. It shows that basically you just covered your initial cost. So a zero net present value, not very sexy, divided by 3170 is going to equal you a profitability index equal to zero. And that doesn't sound very interesting, but for nonprofit organizations and for hospitals especially, or universities, profitability index of zero is fine. It just means that they expect the net present value to be zero, which means that their returns are going to cover their costs, their initial costs. And it also means that they're using a discount factor equal to the rate of return that helped them generate their expected future cash flows. So just go back and take a look at that and make sure you understand internal rate of return. They talk about internal rate of return very, very briefly on page 527, but I think it's worthwhile just making sure we're clear about what a net present value of zero means. It's not bad. It just means that they're able to cover costs.